Okay, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing another one of the. I don't know what to call this. It's one of the quieter streams, because reasons. And today's stream is unfortunately not going to be that long either. It's only going to be like half an hour, maybe 45 minutes if I'm able to stretch it that far. But yeah, I wanted to stream today because we've got a pretty good stream streak going, and I didn't want to lose that streak. I didn't want to, you know, end up taking a day off. So yeah, we're gonna be for today. All I have in mind is that I wanna work on the prompt for the electronics course that I wanted Gemini to generate for me. Give me a second. Let me just set something up for a little bit of background sound. Hopefully, the background sound doesn't get picked up on uh, on stream. Let me also open up my chat on my phone so that I can look at the chat. And oh yeah, um, what we can do here is, what am I doing in this? I think here we can go back and then enter empty. Yeah. And oh, we can probably also deactivate this. We don't need to have this active. I've reactivated that filter, the extra gain filter, the actually third gain filter, the third gain filter uh, that I've created. I've activated that. Generally, I have two of these gain filters set up, but then for today's kind of situation where I need even more of a boost in the audio, I added a third gain filter. Um, yeah, this should work out for days where I have to do some of the more quieter streams. And this is good because in a way this makes it so on days where due to XYZ reason I'm not able to do loud talking streams, I can at least do the quieter talking streams. But yeah, okay. So here I'm going to create, yeah, let's say Gemini electronics prompt .txt or .md.txt. Okay. So first things first, let's save this. Now, here's the thing, right? With this prompt, what I want Gemini to do, let's write down the goal. So we're going to have prompt that's here, and then here we can have goal. The goal or goals, just goal is fine. Gemini teaches analog electronics with the use of microcontrollers. There was something more, right? Yeah, we can further expand on this. So rather than what is it that I was trying to, let's not say rather than. So Gemini teaches analog electronics with the use of microcontrollers. Now, in the past, I have asked Gemini a question about this. Let's also deactivate this. We should come back to Le Robot at some point later on. I don't know if I have that Gemini electronics. That's the prompt. Okay. Learning analog electronics. Okay. Now, hold on here. How do I open a file? Is that E as well? I don't remember. Okay. This. Right. So this was my entire prompt where I gave Gemini like a whole backstory. I was like, hey, so hear me out. Back when I was a kid, I got into electronics. I loved taking things apart, learning how they worked. I also liked taking various components out and connecting them together. Stuff like motors and LEDs and stuff. I would like to pull them out and connect them together and just see them working. Anyways, continuing. Components out and connecting them together. In my later years, I learned a little more about electronics, voltage, current, and other basic concepts and some basic calculations. Hold on. Yeah, didn't go too deep into it. This was all analog. Microcontrollers weren't as widely available back then. Fast forward a couple of years, I got back into electronics, but this time through microcontrollers, specifically Arduino Uno, and a couple of years later, ESP32. That was all digital though, but it still did use some basic analog electronics concepts. I never really dove too deep into analog electronics. I also never got a chance to dive too deep into the calculations for various components like capacitors, diodes, etc. I did learn calculations for resistors and a little bit of BJT transistors. I never learned, hold on. Yeah, I never learned that whole thing about solving circuits. I learned Ohm's law, but for very basic calculations, for very basic circuits, sorry. Never touched Kirchhoff's law. I think it's Kirchhoff's law. I don't know. I'll see how to pronounce that. Now all this has me wondering. Let's forget I know anything about electronics and pretend I'm a complete noob at electronics. Now, in the age of microcontrollers, would I be able to learn various basic and intermediate analog electronics things through microcontrollers? Would I be able to learn about various components and their calculations through microcontrollers? Would I be able to learn how to set up and maybe even solve circuits through microcontrollers? Basically, what I'm asking is, in this day and age, is it possible for a complete beginner to be introduced to electronics through microcontrollers and learn both digital and analog electronics through microcontrollers? And then Gemini gave me an excellent response. There was something more I'd asked later on in that. No, that was a different conversation. So, okay, this was what Gemini. Oh, actually, I think I edited the. Yeah, I think I cleaned it up to show what I, wanted to show, because I had to save this this thing as an MD file. So I kind of wanted to clean it up because I knew I'm going to be coming back to it later on to take a look at it. Okay, so this was Gemini's answer. Gemini said, hold on. Of course, it's a fantastic question that gets to the heart of how electronics is taught today. The short answer is absolutely yes. In fact, for many people, learning electronics through microcontrollers is a more engaging and effective way to learn both digital and analog concepts than the traditional theory-first approach. Here's a breakdown of why and how it works. You know what I could do? What I could do is, each time I'm planning on posting this entire conversation, exporting this entire conversation and posting it on my website eventually, right? I'm also planning on working on my knowledge base, a new knowledge base application that's specifically for my purposes, for my workflow, for my purpose, for my needs, for my requirements. It works specifically for what I'm looking for. In fact, after yesterday's stream, I continued and and did like a whole bunch of research surrounding surrounding all of the stuff that I'm going to need for my knowledge base. I was having uh, I was having lots of conversations with Gemini regarding the whole directory traversal and storing metadata, and what more? Oh, also moving data over from one thing to another. As I was discussing more and more with Gemini, more and more ideas started coming to me. Like for example, it occurred to me that I could benefit from storing file hashes in a manifest file. So initially I was going to have like a global index file in which I would just store the directory names or entry names. That was very basic information that, hey, this is the knowledge base index, and we have these names, these entries. Additionally, I could read the beginning of every file, or every main MD file, and I could. Sorry, I kind of zoned out. I could read the beginning of every file and extract the tags from it, because there's a certain amount of metadata that you can store in TOML form, which is apparently called TOML front matter. That was something interesting for me to learn. I wonder if various markdown parsers, or renderers rather, end up rendering that metadata, or if that's just stored somewhere in the background, or if it gets translated to something else. Actually, I think that might get translated to something else in the case of Zola. Possibly, I think it might get translated to something else. Maybe, I don't know. Either way, why was I talking about this? Oh yeah. So I realized that I could benefit from storing a file hash of every entry. So every entry, let's say the entry is called my first entry, and that's the directory name. Within that directory, I'll also have a file named exactly that, my first entry. I'll need to make sure that the file name and the directory name, they match together. And then additionally, there can be, whatever media files or anything that's required. I can put that in there as well. Why was I talking about this? Well, okay, so for every entry, I'm going to store the file hash, and every now and then, when I'm or moving the whenever I'm moving the entire knowledge base from its local copy over to the Zola directory, I'm going to be writing a tool for that to run a couple of checks. So what I could do is I could check the file hashes, because each of them is going to have a manifest. What I'm thinking is this manifest.toml file. This is what's going to describe what constitutes a database. So we're going to have the root database directory. Within this directory, there's going to be a manifest.toml file, and every other directory in this. Well, it doesn't have to be every other directory, but the manifest.toml file will mention entry names, and for each entry name that's mentioned, there has to be a corresponding directory within that root directory. And I'll write a system to run all of these checks. But yeah, I'm glad that I had that conversation with Gemini, because it gave me more ideas for stuff that I wanted to stuff that I would want to do with this system. Well, anyways, okay, so continuing with what Gemini was telling me. Yeah, in fact, for many people, learning electronics through microcontrollers is a more engaging and effective way to learn both digital and analog concepts than the traditional theory first approach. And yes, I 100% agree with that, because I have tried the theory first approach. You know what? We don't need to view this. Actually, okay, we don't need to view this inside NeoVim, but it would just be a lot easier because, well, I can easily, switch the buffer to the other thing, to this. I can easily switch. But to be fair, I could also do it here. So I can do Frogmouth Gemini explains learning analog electronics. Yeah, so this is our yeah, this is it. Okay. Well, yeah, I can go back to NeoVim. That's fine. So, yeah, like I was saying, it is this is true. At least for me, I found myself gravitating towards microcontrollers a lot more and digital electronics a lot more because it was a lot more engaging. Each time I would try to go into analog electronics, it could just be the path that I was taking, the various materials that I was reading. They took some time to get into the practical stuff. And while I can understand the need for that, as in, while I can understand the need to spend a whole lot of time in theory before getting into the practical stuff, it that's just not something that my mind finds very engaging. So that specific method of teaching just doesn't work for me. I've tried that multiple times over the years and it just doesn't work. So I have a feeling that doing it through analog electronics is going to be much more engaging for me because honestly there will be a lot more activity involved as well because I'm going to be doing the microcontroller side of things and I'm going to be doing the analog side of things. So that should be kind of interesting to play around with. And yeah. Before we continue this, goal. Gemini teaches analog electronics with so and so. Assumption. User already knows how to use MCUs. I'm just going to write MCUs because writing microcontroller each time it's a pain. Okay. User already knows how to use MCUs. Has an ESP32. And has the ESP32 Rust toolchain set up. User just needs to be told what must be accomplished. No. When it comes to taking steps, what do I want to say? When it comes to doing anything doing anything MCU related, user only needs to be told what must be accomplished, not how to accomplish it. I feel like maybe I should give like an example as well. Or should I just let Gemini, because I feel like I'm going to have to go through multiple iterations here of the prompt to improve the prompt we are able to proceed with before we are able to proceed with the final version of it and proceed with the further chapters into it before we are able to actually move forward with it. I would like to run multiple iterations of this and think about every possible scenario so that we can eventually have a proper prompt. Okay. When it comes to doing anything MCU related, assume that the user already knows how to use MCUs. Was I in replace mode this entire time? Why did that happen? Anyways. When it comes to doing anything MCU related, not assumed, assume that the user already knows how to use microcontrollers. And just give high level instructions like, actually, see, this is the point where I don't know if I should be doing it in that way or because I kind of want the entire course to focus more on analog electronics, assuming that you are coming in with knowledge of digital electronics already, and you already know quite a bit about digital electronics, or rather, no, you are coming in with basic knowledge of digital electronics through microcontrollers. So you already know how to use microcontrollers. You know that you can set you can set a digital pin high or low. You can read analog signals from, I guess you read it from the analog pin. What else? What else? There's a couple of other things you can do that I'm not really able to remember right now. But yeah, okay. So what I'm trying to do here, the main idea is that the tutor, or Gemini in this case, shouldn't be telling me how to do so and so thing with the microcontroller. Gemini should just tell me, hey, this take your microcontroller and do so and so thing, and I will find a way to accomplish it. So that way we can focus more on the analog side of things. So okay, when it comes to doing anything MCU related, assume that the user already knows how to use microcontrollers, and so okay, you've got instructions like because I don't want to limit what Gemini is gonna say, like what information Gemini is gonna give, just in case if there's some important information that gets like left out. Okay, when it comes to doing anything MCU related, assume that the user already knows. You know what? Okay, we can do this. Okay. Let's not make it sound formal. Let's say background. User already knows how to program ESP32 with, actually I can be more specific. I have a ESP32 Room 32D, so I can mention that just so it's not assuming that I'm doing ESP32C3 or S3 or something. Give me a second. Right, okay. A user already knows how to program an ESP32 with Rust. User has set up the ESP32 Rust toolchain already. User has basic this is where it gets a little complicated. When it comes to set, should I just let okay to avoid no wait okay we're just creating a bunch of different sections here. Considering users prior knowledge of MCUs and Rust, user can be given instructions about well, what I'm wondering is what if wait, okay, user can be given high level instructions for what needs to be accomplished, and then user can figure out how to accomplish the task. For example, connect GPIO. Should I just let Gemini hold my hand throughout the entire thing? Because here I am trying to make it so Gemini is spending less of the token count with you know teaching me MCU related stuff, and more of the token count teaching me about analog related stuff. I don't know to what extent this is even going to be a problem. But okay, let's carry on with this. Connect GPIO pin 5 to to let's say 220 ohm resistor. Connect other end of resistor to plus of LED. Connect negative of LED to, maybe I should put this within parentheses. Of LED to GND. Yeah. Okay. So that's a good example of right. So then we don't need like a background thing. We can just put this into okay. So we can get rid of this. So this is our info. The goal here, Gemini teaches analog electronics with the use of MCUs. We can get rid of the assumption thing, and then we can focus on just the prompt. But I'm still not sure how I want to go about this. Like, do I just want to wait? Um, User knows how to set up an ESP32 Rust project with the necessary settings. User already has an MCU plugged into their system, ready to go. Now I need to feed this into Gemini. I think I'll start by feeding this into Gemini Web. Yeah, I'll start by feeding this into Gemini Web. And here, instead of prompt, so this will all be part of the prompt. Or, well, info can be okay. I'll see how to, because like info has to be part of the prompt. I don't necessarily need to use the word prompt here, or well, I don't need to use a prompt. I don't need to use the word prompt when I'm putting in the prompt into Gemini. Yeah, okay. So I'm still kind of like, okay, we can go back to reading this. So here's a breakdown of how it works. Microcontrollers are a bridge, not an island. A microcontroller is a digital brain, but it lives and interacts with the analog world. This forces you to learn analog electronics to get anything interesting done. Sensing the world, analog in. Just a minute, we can let this render. Okay. To read a temperature sensor, a light sensor, or a potentiometer, you need to understand analog signals. The microcontroller's analog to digital converter is the tool you use, and it directly exposes you to the concept of voltage levels, voltage dividers, and signal noise. You'll quickly learn why you need a capacitor to smooth out a noisy signal from a sensor, because you can see the erratic readings in your code. Controlling the world, analog out. To dim an LED, control a motor's speed, or generate a sound, you'll use pulse width modulation. While PWM is a digital technique, the result is an analog effect. This naturally leads you to learn about filters, like using capacitors and inductors to turn that digital pulsing into a smooth analog voltage. Then theory follows practice, which is more motivating. Okay, the traditional way of learning is bottom up. You learn Ohm's law, then learn Kirchhoff's law, then spend weeks solving abstract circuits on paper before you ever even make an LED blink. The microcontroller approach is top down. Your goal, I want to build a plant watering system. The problem, my soil moisture sensors reading is unstable. This actually works out in my favor because I recently got a bunch of these modules. So I can probably add that to the list as well. I can add that to the list of components and parts and stuff that are available to me, I can mention that to Gemini, and then throughout my learning process, I'll be able to use those things as well. Though I feel like before we get into that, I would probably need to learn. Okay, so I guess it's not fair for me to say, or it's not accurate for me to say that, user knows how to use microcontrollers, because me, user, doesn't fully know how to do serial communication yet. Um, I'm wondering if I should spend some time doing that. Okay, so um, for the time being, because we are focusing on analog stuff, I can tell Gemini that I want to focus more on using the analog components that I have rather than going anywhere near the modules that I have. I do have modules that I can use to build projects and do more higher level stuff, but for the sake of simplicity, I would very much like to stick to the discrete components, and maybe we could go into ICs if necessary, but I would very much like to avoid anything that involves me doing any sort of serial communication. Yes, okay, we can probably add that to the list. Uh, limitations? Should I say that? Avoid, not limitations. Limitations makes it sound negative. Okay. Because this is an analog. Uh, first off, wait. Analog versus, because I keep using two different spellings. Analog and analog generally refer to the same concept, non-digital technology, or a comparable item, with analog being the standard. Oh, it's an American English versus a British English thing. You know what? Okay. We are going with the British English version. Analog, okay. Where else have I mentioned analog? Let me finish that. Okay, analog. Okay, so that's analog, that's analog. So we are good. Oh, I should also change. Oh no, this just says Gemini electronics prompt. Right. Because this is an analog electronics course, try as best as possible to stick to how do I say it? Stick to interacting with discrete components and ICs rather than going towards modules, which usually require some form of serial communication. Okay. Yeah, that's good. I'm glad that I'm sitting down and writing this entire thing, because yeah, all of this stuff needs to be considered. Okay. Then what other limitation did we have? We can also list out all the parts that are available, right? What should I just say? What should I just say? What should I say? Should I just write parts available or course material? Course material is more like study stuff. Parts. Okay, let's say parts available. LEDs, nuts, LEDs, resistors. Maybe I could make a list out of this. 3V LEDs, let's mention that as well. Assorted resistors, because I have multiple types of resistors. Assorted capacitors, because I have multiple types of capacitors. Assorted diodes, because, well, you get the point. Assorted transistors. I also have 555 timer ICs. We can bring that in as well, because that is definitely 555 timer IC is one of the it's like a staple in analog electronics. It's I feel like it's one of the first things that people get to see in terms of, hey, look, I'm able to program this thing. The basic idea is that with a 555 timer IC, you have, I think, 6 or 8 legs, and depending on the voltage and current, usually current, and how long of the current you're giving, depending on the voltage and current that you're giving to different pins, you can have different types of outputs from the timer IC. So you can use it to do something like blinking an LED, or something more complex, like if the timer IC is connected as like a pin, you could connect it to a transistor, and then that could be powering something more powerful. You can get creative with how it can be used. More recently, I just realized this. More recently, I also got a comparator, two comparator ICs, LM33 something, LM339, I think. Oh, you know what I could do? I could say assorted ICs, and in here I can say, then I can add in, well, no, let's say 555 timer IC, and then down here we can write, because I was going to write the entire list of things that I have, because I do also have, I just remembered, I do also have EEPROM chips of different sizes, so I could probably use those as well. I should make an inventory of the, like, all of the chips that I have, all of the, what I would consider discrete components and ICs that I have, and then I should drop that in here. Oh, opto optocoupler optocoupler ICs. I'll need to mention the model number as well, just so there's reference for what the max current and max voltage of the IC is. The thing is, I feel like as soon as I drop this prompt into Gemini, I'm not going to drop it into Gemini CLI first, because I want the entire first prompt to be generated by Gemini Pro. Even if it's 2.5 Pro, I want it to be Gemini 2.5 Pro rather than 2.5 Flash. First, I want it to be through Pro, and as much as possible in the future, I would like for every single next chapter to be generated with Pro, just so I can get like as much information as possible. Though, I guess I should also consider whether there's going to be that much of a benefit of doing, Pro versus Flash. Yeah, I should consider that. I don't know if it's going to be that beneficial. I just realized I was supposed to be doing a quieter stream, and as I was speaking about this, I kind of just like got in the zone. I didn't even like zone out. I got in the zone, and I don't know if I've been being loud, but anyways, um, EEPROM ICs, and then I have comparator ICs, logic, logic gate ICs. I'm gonna write the exact model numbers. Then I also have shift registers. I have to see if I'll have to set up a circuit for this, but I do want to see if shift registers, if I could go about programming a shift register directly from, actually I think the shift register requires SPI communication, doesn't it? Wait, I don't remember. What was it? 74HC? Not 595 though. Oh, maybe it was 595. Okay, my bad. Because it says it's 8-bit serial in, parallel out, shift register. Because it's 8-bit, we have to be passing in those signals like in an orderly manner, right? In a manner that the shift register knows how to decode. And so there has to be some sort of protocol being used for communication. Just a second. There's a clock pin. Okay. All right. Yeah, it has a clock pin. So whatever I'm connecting it to, it's going to need to be able to. Yeah. So now, man, let's remove shift register from this. There was a decoder. We can look at the. We can probably add decoders to this. I'll have to look into that first, because like I don't know if even that requires some sort of clock signal, because anything that requires a clock signal, we probably actually wait. I I'm trying to avoid serial communication. Do I want to avoid clock signals as well? Like, do I want to avoid clock signals entirely, or can we like let this thing sneak in? Because I feel like clock signals are more of a thing that I need to explore later. And also clock signals, that's, yeah, I don't know. I'm not too sure. Should I involve that? Because okay, but then okay, if we are looking at it in that way, I don't know if the EEPROM, I don't know if the EEPROM ICs can be, because they're meant to hold data on them. Like you're meant to be writing data to them and reading data to them. They are very much digital ICs. So there's definitely going to be some sort of like clock signal or some other way of communicating. I should probably remove this. We can leave logic gate in there. Decoder, probably get rid of that. Optocoupler, we can use it, definitely. Comparator we can use, logic gate we can use. In fact, comparator, I might actually be able to get proper, how do I say this? Because like apparently the idea behind comparators is that you give it two inputs and then it tells you which one is higher than the other. And then based on that you can create logic, and then with each of the logic gates they have their own truth tables. So you have, AND, OR, XOR, NAND, and whatever other combinations. But yeah, you can actually use the logic gates without needing to connect them to a microcontroller. The thing is, they are operating on digital logic to a certain extent. So while you don't need a microcontroller, you also cannot leave the pins floating, as in you have to connect something to them. If you don't have a microcontroller, then you are most likely connecting either positive to them or ground to them. So either you're connecting VCC to them or you're connecting ground to them, like directly. Um, I haven't tested out the comparator yet. I'm still learning about voltage dividers because I wanted to be able to test out the comparator without having to connect it to a microcontroller. But I only had I only have like in my case, I want to keep the circuit simple. I don't want to introduce two separate power sources. So I needed to find a way to cut down 3 volts, which is two AA batteries. I needed to find a way to cut that down to a lower voltage. And turns out that if you set up a voltage divider, you can split the voltage in half. So I'm still learning about voltage dividers. But yeah. The initial lessons, I'm really hoping they focus on the discrete components. Oh, you know what? We can do that. Um, should this be, uh, let's say expectation? I don't know what word to use here. Um, requirements, I guess. But then requirements would be, okay, expectation. Because this is an analog electronics course, try as best as possible to stick to interacting with discrete components and ICs rather than going towards modules, which usually require some form of serial communication. Okay, then, because this is an analog electronics course, try to stick to learning about discrete components more. Did I spell components wrong? Components. More than try to stick to learning about discrete components more. Oh, you know what? Wait. Give more importance to learning about discrete components. Give more importance to learning about discrete components than learning about ICs. Once discrete components have been covered, in the future chapters, we can look at using the ICs in creative ways. Okay, right. Should I be removing something from this? Because, okay, the optocoupler, I definitely don't need to remove from this because that is absolutely something that I can use to completely isolate the circuit or two circuits if need be. But once we do get into transistors, speaking of which, I want transistors to be taught before diodes. I should also look into what other transistors I have. I should also mention I have resistors, I have capacitors, let me also mention these are through-hole components. These are not SMDs. Oh, yeah, we can also mention breadboard, switches and buttons, and jumpers. Oh, we can also mention AA battery. Though we don't, no, the power is going to be coming from the ESP32 directly. Yeah, the power is going to be coming from the ESP32 directly. I am not entirely sure if I want to attach a 3-volt source because hopefully by the end of this course that we learn, I'm going to know enough to be a little more comfortable with combining voltage sources, because I don't want to mix up, as an example here, I don't want to mix up a battery source with an ESP32 power source. Even though they're not going to be all that different, the battery source is going to be 3 volts and the ESP32 is going to be 3.3 volts. I still don't want to like mix them up because I'm not that comfortable with it. But yeah. Okay, I still need to, sit down and think about this. Fortunately, I have this as well, so I can like read. Oh, I do have potentiometers. I just remembered that. I think I have. So I'm gonna say assorted, but what I have is 5K and 10K potentiometers. So I'm just gonna say assorted, and later on I can mention that okay, these are the values that I have. I don't remember if I have 3K, but I definitely have 5K and 10K. What else? What else am I looking for? Sorry, zoned out. Okay. Yeah, 555 timer IC, optocoupler ICs, comparator ICs, logic gate ICs. We can look into the ICs later on. For now, we're going to focus on the discrete components. I need to see what other discrete components I have. Like maybe I might be missing some, but these are definitely the more important ones. Actually, potentiometer should come down after diodes. Yeah. Okay, what else? I'm gonna need to spend some time sitting down and writing down this entire requirements list. So we have the parts available We have the info, the background info. I need to see if I want to, mention this part. Like, okay, I have prior knowledge. Oh, I do also have the expectation to not, you know, do any sort of serial communication, rather than going towards modules, which usually require some form of serial or parallel communication. So what I'm thinking is I could what I'm thinking is I could I lost my train of thought. Yeah, I don't remember what I was gonna talk about. But okay, that being said, I just noticed that we hit the 1 hour mark, and that's pretty awesome. I think I'm gonna end the stream here. I'm not gonna raid anyone today, but I'm glad that I was able to at least stream today, and we got some of this done. I still have like a long way to go. Oh, I was gonna mention that the entire prompt that's being set up, and the entire course that's going to be like the entire conversation that's going to be the result of this prompt. In between it, I'm also going to drop in pics of stuff that, the circuits that I set up, so I can, that way at least I can show that, hey, yeah, I was doing this work and this work and this work. But yeah, that's going to be it for